all you Gretas and Chutezcats out there. Welcome to Unit 4, Section 4, Earth's Atmosphere. So let's get started. Here are some really cool cloud pictures. None of these are photoshopped. Some different things. You get this lens-shaped cloud over a mountain sometimes, which is kind of pretty. They made a DNA cloud. This is a storm front rolling in. It actually really looks like that. This is the top of a thunderstorm. You usually don't see this view of things unless you're in an airplane. Actual real clouds. Not photoshopped. I don't think I'd want to be right here. So if you look up Felix Baumgartner, he parachuted down from 24 miles up, I want to say. So he was way up there and actually parachuted down and survived and had the record until I think a couple of years ago. So there's some cool videos on it. We're not going to watch it right now, but look him up if you want to check that out. So structure of the Earth's atmosphere. Actually getting to content, now we're on page 22 of your packet. So we have four main parts to Earth's life support. We have the atmosphere or air, we have the hydrosphere or water, geosphere is your rocks and soil sediments, and the biosphere is living things. So we're going to be focusing on the atmosphere. So why is it important? It gives us both oxygen and carbon dioxide. We need oxygen to breathe, and plants need that carbon dioxide thing. So both important. It will help absorb solar radiation. A lot of solar radiation gets absorbed in the atmosphere. It helps moderate our climates, and it transports and recycles water and nutrients, all of which are super important. So atmospheric pressure, if you think of it, we are located kind of at the bottom of an ocean of air. So just like water pressure is caused by weight of water, the deeper down you go, the more pressure you feel in your ears. Atmospheric pressure is caused by the weight of air. So we actually have more on us here than we do up. Oops, went the wrong way. There we go. So pressure is weight over area. So if you think of a column of air from the surface to the top of the atmosphere, that is one area that you're looking at. So all of the molecules contribute to the pressure or weight at this altitude, and then only these guys would contribute to the weight at this altitude. So you're looking at a full column of air, and then you're just kind of going up. So the surface air pressure is the weight of all of the air in the column above that unit area. Understand as altitude increases, the pressure is going to decrease. When you go up in an airplane and the pressure changes and your ears pop, the higher you go, the lower the pressure is. So there's an inverse proportionality to that. I might know that. So composition of the atmosphere. Permanent gases, we have nitrogen and oxygen are big ones. Most of the atmosphere is nitrogen, about 20% is oxygen. And then we have variable gases. Water vapor can be anywhere from 0 to 4. The more water vapor, the more rain you're going to have. Water vapor tends to affect the weather of an area, not the climate. Carbon dioxide is that's a big lie. When this was made, it was about 350 parts per million. We're over 400 parts per million now, which is really bad. Methane is about 2 parts per million, and ozone is about 40 parts per billion. So these are some approximations of the percentage of different gases. So we have different layers of the atmosphere. Troposphere, which is where we are. Stratosphere is the ozone and greenhouse gases. Then above that, you have mesosphere, thermosphere, and exosphere, which is pretty much space. Now, what is used to define these layers? Any guesses? The answer is the layers of the atmosphere are arranged according to temperature. So the temperature changes with altitude. So as you go up, things are going to happen. Oh, so sorry. And then you have pauses in the layers, and these are the transition zones between the temperature changes. So we have troposphere, stratosphere, mesosphere, thermosphere. And after troposphere, we have a tropopause. After stratosphere, we have a stratopause. And after mesosphere, we have a mesopause, and then up thermopause. But then they're going to allow that transition zone to happen between these different temperatures. So in your packets, there's an activity that you're going to do. We'll be doing it in class or online, depending if I see you or not. So I'm going to skip a teeny bit of the notes because we'll be addressing that in class, and virtual kids, I'll get that out to you. And then we're going to jump to this next thing. So here is a super official graph of temperature as you go up. So we're going to actually start at the bottom. So air is fairly thin down here where we are, and temperature is warm. The molecules are further apart. As you go up into the stratosphere, you can see that as you go up, it's going to get colder. But then once you hit the stratosphere, this forms the ozone layer, which helps trap heat. And when that happens, it's going to get warm again. So once you get to the top of the stratosphere, it's warmer again because that heat has been trapped. When you hit the mesosphere, after the mesopause, air is going to become thinner again, all the way up. And then last but not least, when you hit the thermosphere, oh my goodness, we have a lot of energy in both UV and X-ray radiation that's being absorbed. We're definitely closer to the sun at this point. And it feels really cold because the molecules are so sparse and far apart, but it is actually warm. So something that's kind of cool. There's a couple articles that you guys can look at and read that have to do with this section. Feel free to look through those and see what questions you can answer. That will definitely help your comprehension of the stuff. But we have finished this section. So before we go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.